AOPS number theory 5.32. There are 2,000 cells in a particular jail. The cells are numbered 1 through 2,000 and each contains one inmate. One night, while all the inmates are asleep, a series of 2,000 computer glitches occurs. First, the computer unlocks all the cells. Then the computer turns the locks of every evenly numbered cell, which is 2, 4, 6, etc., relocking only those cells. The computer then turns the locks of every third cell, locking those cells that were unlocked and unlocking those that had been relocked. The glitch goes on through the first 2,000 natural numbers, where for each natural number n, the computer turns the locks of the cells that are multiples of n. A. For a cell numbered m, which of the 2,000 glitches affects that cell? So, for that cell numbered m, then it must be a divisor of m that would affect that cell, because a divisor of m means that m is a multiple of that. So over here it said that it affects the locks that are the cells that are multiples of n. So it has to be divisors of m to affect that cell. Now B. How many of the prisoners are awakened to unlocked cells? So, if all of them are locked, so the first time the computer glitch occurs to that cell, it will be unlocked. The second time it will be locked. The third time it will be unlocked. Fourth time it will be locked. Fifth time it will be unlocked, etc. And it must be odd to be unlocked, because if it's even, you see, for 1, 3, and 5 it's all unlocked, but 2 and 4 are all locked. So if it's odd, then that means it must be a perfect square. So the perfect square, the biggest perfect square less than 2,000 is 44. So 44 squared, so it's 44. So 44 prisoners will awaken to unlocked cells. AOPS number theory 5.33. Find the sum of the perfect square divisors of the smallest integer with exactly 6 perfect square divisors. So since it's a perfect square, then the power must be even. So you could either have one exponent with 6 even choices as the power, or you can have 2 exponents with 2 and 3 even choices. So it could be 2 to the power of 10 if you want one exponent, and it's 10 because 10 can have the 0, 2, 4, 6, 8, and 10, so that's 6 even choices. So 2 to the power of 10 is equal to 1024. Or if you want 2 exponents, it can be 2 to the power of 4 times 3 to the power of 2, because for 4, it can be 0, 2, and 4, so that would be 3. And for 2, it's 0 and 2, so that's 2. And 2 to the power of 4 times 3 to the power of 2 is equal to 144. So 144 is the smaller of these two primes, because, yeah, so you want the sum of the perfect square divisors, so that's equal to 1 squared plus 2 squared plus 3 squared plus 4 squared plus 6 squared plus 12 squared, which is equal to 1 plus 4 plus 9 plus 16 plus 36 plus 144, which is equal to 210. So the sum is 210. UPS number theory 5.34. Find the product of the positive divisors of 6,480 that are multiples of 12. If it's a multiple of 12, that's all the factors of 6,480 divided by 12, which is 540. Well, 540 is equal to 2 to the power of 2 times 3 to the power of 3 times 5 to the power of 1. So if it is a multiple of 12, it can be written as 12t. So T 540 is equal to 3 times 4 times 2, which is 24. So 24 positive divisors of 540 is a multiple of 540 to the power of 12. So all the multiples of 12 would be 12 to the power of 24 times 540 to the power of 12, which is 77760 to the power of 12. That would be the product of the divisors.